one decade, we are hearing the name called Internet of Things. So let's understand what exactly. So there is not a clear definition of the IoT. I mean, it's we don't have a clear uh, block diagram because it completely changed on the requirement of the people. So we can, in a very high level, we can define Internet of Things as a network of physical objects embedded with sensors, softwares, and other technologies that connect and exchange data with other devices. So it doesn't matter like how it is connected, but it is connected and what we are going to connect. So if we say Internet of Things, we have to connect each and everything with the internet, no matter what the device is. It's an electronic device or it's a non-electronic device. We have to connect each and everything to the internet based on the requirement. For example, suppose if you want to monitor your door, it's open or close. So this can be this can be even connected to the internet via some sensors. So we have the door sensors, which can tell the door is closed or open. Today we have the actuators as well, which can uh, close the door if it is open, and if it can open the door if it is closed. So you can control your gate from your door from anywhere, and you can monitor the status of your door from anywhere. So a door itself is not an electronic device, but by using certain sensors, certain actuators, we can connect the device, I mean, the object to the internet. Again, when we talk about uh, the basic electronics, what are used here? So it's not necessary the object which is controlling the device should be and uh, should be a device which should have the capability of connecting with the internet or network. Uh, use using the using certain hardware protocols or using certain local radio protocols like Zigbee, like Bluetooth. We can even connect no IP devices to the internet using certain gateway. So let's see the definition. So Internet of Things is basically the network of physical object, device, vehicles, and buildings and other embedded items, like embedded electronics, software sensors, and which enables them to connect to the internet or intranet. So uh, why we use the word intranet? Because for security reason, so many companies basically they connect their sensors and devices to their intranet only. But again, because we have the VPN today using that's enabling the users to control their devices across the globe by just staying in the intranet. So as we discussed, like IoT devices are of two types: no IP-based IoT devices, where we have like the protocols Bluetooth, Zigbee, sub-gigahertz. So they need a edge gateway to basically get connected to the internet. So gateway is acting as a IP devices because definitely they need an IP-based device, a device which should have the capability to get connected to the internet. So we'll be seeing this in our block diagrams. And another one is the IP-based uh, uh, IoT devices. So these are basically, for example, ESP32, Raspberry Pico Pi. So they have their own Wi-Fi capability using which they are able to get connected to your router, and through which they can directly connect to the cloud and exchange their data with the cloud. So uh, from past one decade, many companies are working on IoT. So uh, they have not used the term IoT, but they have used different terms, but the names are different, but the concept is same. For example, Digi International, they used to call this as machine-to-machine communication, no matter where the machine resides. They were residing in a different geographical location, different regions, but they used to communicate with each other using the cloud. So they have their own cloud infrastructure. Using that, they used to communicate with each other. Uh, so the name given them by was machine-to-machine communication. They never used the word IoT until late 2016s. And Internet of Everything, this one name was given by Cisco. And Industrial Internet, this name was given by GE. So these were the different names given by different companies, but the concept was same as like their objects were and their things were residing into the different locations, and they were all the data were getting collected in the centralized location, and they used to validate the data. They used to they were using that data to see the conditions of the system, to basically analyze the health of the conditions, and sometimes they used to control the system. They used to take the appropriate actions by seeing the data. So today, where we have the IoT, so sensors. So a lot of sensors has been deployed into the different geographical locations, different regions, from where it's collecting lots of information. For example, weather. So whenever we analyze the weather of any city, we are doing some forecasting. So that's basically using some. Today they are using AI to basically forecast the weather of a specific location. So this AI basically is making use of the data which has been logged earlier. So the data has been collected from various sensors which has been deployed in the various geographical locations of the city. And based on that, they are finding that what's going to happen in the next few hours or next tomorrow or next week in the wearable. So today, lots of data is getting collected from wearables. Even the health condition of the people, like how much they walked, how much what's their heartbeat. These all data is getting collected via the app, and it's getting uploaded to the cloud, and it can be used. Even if you see, Google is using this to show you sometime that how much steps you have walked, uh, and they will compare your data with others. That where what's your rating? Where how much? I mean, how much others walked and how much you walked, and where you stand. So smart appliances. So I mean, you can monitor your appliances from anywhere in the world today. By I mean, you can control its temperature, you can control its operations. In the healthcare industries, where basically I mean, some critical conditions of the of patients are getting monitored from the remote locations. Doctors are monitoring the different parameters of the patient from remote. Then smart school buses where parents are monitoring the movement of their kids, and soil moisture level monitoring. So when most of the time when from people are going out of the home for a long time, so they keep on monitoring the moisture level of their favorite flowers in the pot, and they're able to control water sprinkling based on the moisture level. In the transportation, where they are monitoring the track condition and different uh, health conditions of different uh, aspects inside the train. I mean, inside the moving train. For example, wheel wheel condition, engine condition. Um, and a couple of years back, Amazon launched the IoT button. Using that, a person can place an order. So these buttons used to be installed in the home, and if they used to see they need the supply, they used to just press the button, and the things were getting ordered, and over a period of time, it was getting delivered to their home. and smart wind turbines, which basically G is using. So here, based on the wind direction, they can change the direction of this fan to extract the maximum efficiency from the wind turbines. So basically, it's helping a lot to increase the efficiency of the product and to manage the devices efficiently. Okay, now coming to our hardware. So uh, we have developed some prototypes using different microcontrollers. So the reason why I choose STM32 H7 series, H7 is all high performance series. So this is one of the very high speed microcontroller which runs on 480 megahertz. And definitely with this speed, we can definitely meet the real time, I mean, the deadlines in the real time applications. So if I compare a microcontroller with a microprocessor, so definitely a microcontroller is much efficient than a microprocessor because it's having all inbuilt peripherals. It's working on a complete flat memory model, unlike uh, microprocessor, which is having a memory management unit, which creates the latencies. And on the top of that, most of the microprocessor is having some sort of OS, which again creates the software latencies. When coming to the microcontroller, so it works on a flat memory model, no memory management unit. It's all flat memory model. So the firmware what we write in the microcontroller are very thin. So if I compare 480 megahertz microcontroller with a 1 gigahertz processor, so still I say the 480 megahertz is much efficient than 1 gigahertz microprocessor, which is running the embedded Linux in that. Yes, both are having their own pros and cons. So again, it's having plenty of memory, so 2 MB of flash, which is really very big in terms of firmware, where it's all where we are writing the bare metal code, and 1 MB of the RAM. So that is again, I mean, these both size of the primary memory basically makes us to write huge and big applications in the embedded controller. It is having a connectivity. It provides us the connectivity using this Ethernet SPI I2C, UART USB, CAN, plus it's having other communication mode as well, like sub-gigahertz and all, USB. Despite it's running on 480 megahertz, it's power efficient because uh, the time when we are not making use of any particular peripherals, we can switch off that peripheral. So at that particular time, we save a lot of power. And that's why the microcontrollers are much more efficient in power saving. So because of its high speed, it can perform a lots of data locally. And hence, it is reducing the latency time because it is the latency in the in terms of sending the data to some centralized location and getting processed there and then getting back the answer from there. So instead of that, we can process the data locally and we can take the decision. Again, since it's having plenty of memory, we can integrate some of the edge AI libraries inside it, like TensorFlow Lite. TensorFlow is one of the AI library used in most of the high-end microprocessors or in the servers. But a TensorFlow Lite is a basically subset of TensorFlow with a small form factor, which we can easily integrate in our uh, STM32 microcontroller, especially in H7 series microcontrollers, because it's having plenty of memory. This is just one example of uh, IoT. So most of the time, it's not necessary that we need a cloud. We can develop an IoT systems without a cloud, but it's easy, safe, and cheap to develop the Internet of Things prototypes using or products using cloud, because it provides us lots of securities, a lot it's easily accessible, it's deployed into the multiple countries, so controlling and transferring the data is very easy. It provides a lot of services um, like AI, like machine learning, like logging of the data, performing data analytics. Everything can be done using the cloud because clouds are having a huge processing power. So this typical example states, here it's showing, this is an edge gateway which is connected to the digital ocean cloud. It can be anything. You can use AWS, you can use Microsoft Azure. So here, this edge gateway is connected to the digital ocean cloud, and here the connectivity is Ethernet. Locally, it can be any of the radio device. In this case, we have the Zigbee, and between this gateway and the Zigbee, the communication is UART. So this Zigbee basically provides us mesh networking. So it is having the capability to connect with multiple uh, edge nodes. So this is called edge gateway or edge coordinator. So coordinator is always attached with the gateway. So gateway via coordinator is able to communicate with multiple uh, edge nodes. So this is one of the edge node. And if the edge node is not within the reach of this coordinator, then the other edge node, say I can say edge node 2, which is deployed somewhere here, and it's not able to fall on the range of coordinator, it's not able to reach the coordinator, then it will communicate with coordinator via edge node 1. That's why it's called as mesh network. So point to point communication. So this point to this point and this point to this point. If this is not able to come within the coordinator, and if it's a movable object, it moves after over a period of time here, and it comes in the range of coordinator, it will again start communicating with the coordinator. And they are very much self-healing in the nature. So self-healing in the sense, so if you move them out of this network and it goes beyond the reach of node 1 and coordinator, so it will be silent, it won't be communicating. But as soon as it reaches within the network of node 1 or coordinator 1, it will start communicating with them once again, because the self-healing is running in the background. It keeps on trying to find the network in the background. So here in this condition, so in this case, the coordinator is communicating with the node, and the node is again attached with one of the uh, controller using the SPI interface. And when the data, when a user is sending some control, it reaches to the, it's going to hit the network first, and from there it's going to reach to the net gateway. From there, it's via this coordinator, it's reaching out to the uh, edge node, and then based on the condition, like what are the device you asked to control, either this bulb or this fan, it takes that decision and it controls it, and then it sends the acknowledgement back that it has done, and this acknowledge travels back again to the users that the operation has been performed. And today you might have seen like uh, many many service providers, basically like Wipro, they have launched certain switches, and Amazon is also having their own smart switches. So you can control those switches using your voice. So here, this Amazon uh, Echo, basically it is connected to one of its cloud, which is mostly meant for voice processing. So here in this device, your voice is getting converted to data. The data is getting pumped to the Alexa cloud. This is a separate cloud. And this cloud, from here the data is getting sent to the Lambda, which is deployed somewhere else. Uh, it's sorry. So basically, AWS Lambda is again one different entity, and the data is getting pumped to the process data is getting pumped there, and which is controlling the IoT devices. So this is one of the prototype which we have developed. Here, one STM32 microcontroller has been deployed, and which is basically able to control the fan, and it's reading the data from one of the temperature sensor, which is called DHT11. So user basically are able to control this fan and able to see this the live temperature sensor actually. So before I show the prototype, so just wanted to stop here and ask if any of you is having any question on the theory part. Okay, I'll just go ahead. So I'm just opening my app. So this can be controlled via uh, our mobile app as well. If you have any MQTT app, you can control these devices using the, because we are using the protocol called MQTT. And at this moment, whatever we have done, it's all over the unsecure line. It's not secure at all. We have not implemented SSL yet. It's all very much open, and anyone who knows our IP can control the data and can monitor the data. So this is one of the app, the PC-based app, which is basically based on MQTT. So I'm just going to connect to this. So as soon as I'm connected, I'm able to see it's getting some data. In every 5 seconds, we'll be getting some data. So I just stop here. So from the remote devices, I'm just receiving two different type of data. So here, this is one device, this is another device. So this device is basically deployed in outside my home, and you can see the temperature. And this is inside my home, so you can see the differences in the temperature. And these are two different microcontrollers. This is H7 and this is H5. So we are able to read the humidity since it's a JSON. So uh, the parameters got shuffled. We don't have the control. I mean, there could be one way. I need to explore that. I have not yet explored yet. So there is a distance measuring equipment which is able to measure the distance. So presently, it's monitoring the height of my roof. So which is 1.578 meters from the table from where this sensor has placed. So this two data is completely getting pumped from two different systems. So just a minute, I can show you something. Okay, I'll just stop here and answer a question. So yeah, the reason why I selected STM32 is because this is an industrial grade microcontroller. So you can definitely make use of ESP32. But if I am going to control a lots of devices, Then I definitely prefer STM32 over ESP32. So for example, if you see the number of GPIOs provided, so we get almost 240 IOs from the STM32. It's having a lot of inbuilt peripherals, like it provides me 16 timers. The speed is very high, like 480 megahertz. So this makes STM32 much more superior than ESP32. So for its prototyping, for learning, definitely ESP32 is good because of its cost, its availability, its size. Uh, but when we talk about the industries, okay, so then most of the industries, almost 99% of the industries are using the STM32. Okay, so if any of you have deployed this or downloaded or running this uh, app, so you can I can just tell you the IP. That's 139.59.24.104. So if you can make use of this IP to connect to this device, and your port should be 1883, and then it will ask you the uh, topic. So we have two different topics, the in temp and out temp. So using this topic, you can monitor this census data, and even you can control one of the fan which is connected to my system, my controller. So I'm going to show you that. So just want to check if my fan, if my fan is visible.
Yes, it's visible.
Sure. So I'm just going to enter the value here because this is what payload we are sending, and based on this payload, the microcontroller is making the decision that it has to turn on or turn off. Okay, I need to connect it first. And then if I send 0, it has switched off. To turn it on again, once I will just send once again. So even you can control this from far location. Okay, so coming back to our presentation. So here we have developed this prototype. So the question is once again, so okay, before explain why MicroPython, so I will just tell you here everything has been developed using the MicroPython. So I have not used any C code. Definitely, MicroPython is developed on the top of C. All the basic code, all the hardware abstraction layer, all the drivers and all the middleware, everything is written in C. And the Python's interpreter has been customized and developed for microcontroller, which has also been integrated with this ecosystem, and this is named as MicroPython, which is basically running inside this microcontroller. So again, the speed of this particular microcontroller enables us to basically deploy the things easily. So this complete prototype took me only 30 minutes. So why we prefer the MicroPython for IoT? So because it's a very much lightweight Python implementation, especially meant for microcontrollers. rapid prototyping, because I told you I just took 30 minutes to develop the complete uh, prototype here. It just, I mean, if I will develop the same in C, which I have done in the past, which took me almost a week time to develop everything. It's having lots of inbuilt libraries because I've never even looked at how DHT11 sensor works. I have just downloaded the DHT uh, app, I mean DHT library, integrated with the MicroPython and flash the complete MicroPython inside the microcontroller. So it runs very efficiently. So you can see we are not having any lag. Even some of you want to try, you can definitely give a try. You can control the things from there. So then again, it's a very easy to integrate any library. For example, like if might have be used like NumPy in Python. So the same a custom version of NumPy named as QLab is available for the MicroPython. So you can just download, just need to build, because no need to customize anything. Just need to drag and drop the things in a folder, which is known as user C module. You can build, you can flash, and you can run. So what we have done here, so we have customized our MicroPython with various libraries for STM32H743ZI. We are collecting the temperature and humidity data via the DHT11 sensors and sending it to the cloud. We are connecting the distance data from VLX53N1X sensors and sending it to the cloud. We are controlling the fan. We have deployed and tested the MQTT broker in the cloud. So basically, this is my own personalized cloud where basically I have deployed my own Mosquito broker, MQTT broker. So then we have tested this particular application from various platforms like Android app, then PC app, web-based app, then our own developed command line C code. So we have different type of cloud infrastructure today. So this is from DG International, DG Cloud, Azure from Microsoft, Google, DigitalOcean, and Amazon. So I mean, it's completely based on us, like based on the application, we can choose any or the cost, we can choose the cloud. So next question is why MQTT? So basically the full form of MQTT is Message Queue Telematics Transport. So this is a very lightweight protocol which is developed on the top of socket. So if your system is having any sort of TCP/IP protocol, so in our case we have LWIP. It's called lightweight internet protocol. So if you're using your Android phone, so Android phone is having a full-fledged TCP/IP protocol. Our PCs are having a full-fledged TCP/IP protocol. In microcontrollers, we are running a very light version of the TCP/IP protocol known as LWIP. So here, basically, this is an application protocol. This is completely an application protocol, which is developed on the top of socket. So, which is basically a transport layer of TCP/IP. So this is very much lightweight in nature. This can be easily integrated in any of the systems, even in the LWIP, which I have done here. It almost don't have any overloads. It provides us a publish and subscribe mechanism, which is basically the property of TCP/IP layer. Our TCP/IP layers basically provides the publish and subscribe mechanism. So you can subscribe a specific topic and you publish the data on the topic, and whoever is going to publish on that particular topic, you will be getting the data. Similarly, if you publish on a particular topic and there could be a number of devices around the world who's connected to the same cloud, and they have subscribed to a particular topic, they will be getting the data. So it this publish and subscribe mechanisms basically helping, making MQTT to to easily uh, develop the two-way communication between the app and the devices. So that's all from my side. So if anyone of you is having question, you can shoot me now. Yeah. So uh, MQTT basically, I told you, like it's an application protocol, and it's having many different type of versions. So the datasheet of MQTT can be downloaded from the net. If you can download the first version was 3.1.1, and I'm also using 3.1.1. So it allows you, basically it gives you various APIs, which using that you can basically subscribe a topic, you can publish over a topic. It provides you a different basically a quality of services mechanism. Using that, you can select, or you can basically choose the reliability of your data. So if some of your data is very critical, and if you want basically to your data to get delivered for sure, then you can choose a quality of service like 2. If you it's a non-critical data, you keep on just broadcasting the data, then you can choose a quality of service as 0. What if device gets multiple input at once from these different users? Yes. So it will definitely try to process all, um, but it will definitely you will see the output from the last received data. So that's definitely the case, because there are a lot of people who keeps on for example, if you're home, so you and some of your family members, so both are trying to control the fan. So if you are trying to switch it on and other one is trying to switch it off, so both of you send the data, system will definitely get both the data. Depends on like if what quality of service you have selected. Because if you have selected quality of service as 0, then there is a possibility that it may miss one of your data, because the time might it was processing, and it might have missed, because see, it's all single core microcontroller, and there is a possibility that it was under processing, it was under some it was performing some operation, and it has missed the data which has been received by the Ethernet packet. So it will not process the data. But if you might have selected QS2, quality of service 2, then your cloud will know that this data was not, because it was not acknowledged. For in TCP IP connection, which is different from UDP, for every packet what you receive, you acknowledge. So if you have not acknowledged, cloud understood that you have not acknowledged, so you might have not processed data. So it will send that data once again, and then you will definitely will get that data, and then you will process that data. So in that case, when two guys are trying to send the same data, or trying to control the same equipment, then definitely you will see the output which it has received at the later stage. It will process the last received data. Okay, in that case, it is going to turn it on. It will try to turn it on, which is already on. So you won't see any differences there. But if you are going to, if you when you change the state condition, then only we'll see the result. It is completely it completely depends on like how you have written the code. For example, I'm going to show you some code. Okay, I'll quickly walk through this idea as well. So if you send me the fan speed like on, so see here, it is basically trying to turn the fan on. So if you send it, you keep on sending one, so it will do the operation again, which basically a microcontroller will understand that okay, it's already on, so I don't need to perform any operation, which is taken care inside this API. Okay, next. Uh, can you please explain me what is ICS? ICS space? Okay, industrial control systems. Yeah, I mean, uh, there are a lot of application in the industrial control systems. For example, uh, I will just give you an example of sectionized valves. So our um, refinery systems in India. So in Bhatinda, Punjab, we have one refinery, HPCL's refinery, and what they do is like after so they take the intake for all these refineries are crude petroleum. It's like a kind of black oil, and after refineries, after the product of refinery is basically uh, gas, I mean LPG, and then petrol, then diesel. So they pump this in a single pipe from Bhatinda to Mumbai. The length of that pipe is 1,000 kilometer, and in between, because they can't take a risk if suppose the pipe is getting broken somewhere in the between, so you will lose a lots and lots of petroleum product. So what they do is they have created sectionalized valves in every 25 kilometer. So every sectionalized valves are having a huge bunch of sensors connected there on both the sides. So uh, one is the inlet and one is the outlet. So at the inlet, it keeps on monitoring the pressure inside the pipe. So if suppose someone breaks the pipe and the data is getting leaked, I mean, sorry, the oil is getting leaked, then what will happen? Both the side of the sectionalized valve, which is 25 kilometer apart, they will sense that pressure is there is a drop in the pressure. Then what will happen? It automatically it will close um both the valves. So at least at most the maximum of what the 20 for that per 25 kilometer only we will lose the petroleum, but remaining petroleum will be saved. That's one thing. Another thing is it's having a telematics unit, so it will start informing all the authenticated persons, like all the GM and everyone, that there is a problem at so and so location number, like the ID number of that particular sectionized valve, uh, geographical locations with coordinates. So this is one of the example I have seen. I mean, a few years back. Apart from this, uh, this system is getting deployed by Central Water Commission. Uh, I mean, they were thinking to deploy this. This is already done in US by Sutron. So they keep on monitoring the rivers. So they have deployed a lot of sensors in the river. So they get to know about the flood much before the flood arrives to a particular location, because they have deployed the sensors like 100 kilometers apart. And if the flood is arriving, because whenever the flood comes, it takes a lot of time, because it's not like flood is starting from that point, it's coming from somewhere else. So they keep on deploying a lot of sensors. So the sensor keeps on telling the level of the water is this much, the speed of the water is this much, and it's coming with this speed. So they know with this speed the flood is arriving, and they know the expected time will be much lesser than what the speed it is telling, because in between there will be many canals will be which will and the level of water may also be differing, because there are many canals in between which will be joining that river. So they take appropriate action. Okay, so if uh, someone has already, installed this app and you wanted to test it, is your question, Mohammed, your question is related with this app, or you want to basically, it's a generic question. It's okay, you can speak. You can unmute your mic and speak.
So nowadays, like even every buildings and all, they are going for that smart switches and all, right?
Yeah, yeah,
To
yeah,
for auto controlling and to save the
mhm,
electricity
yeah,
consumption when it is not occupied and all.
yeah, yeah,
So we are looking at the cost efficiency. If we want to go for this green buildings and all, BEE, it is a government implication also to implement this advanced, technologies towards saving the energy, wastage of energy, and because once energy is produced, we can't store it, right? So based on that, that sensors everywhere it is using. But
yeah.
in so what is the costing of that? If you want, like, is it cost efficient? What is the return of investment we get on this kind of thing? If we want to implement at not at large scale, government sponsored and all, they have sufficient budget and all, they can implement. But as an
Yes.
individuals, if you want to adopt this,
Okay, so if you see today we have very cheap microcontrollers available, so we can make use of that to basically develop a very cheap prototypes. And even if you see internet is so cheap, so and even if we can definitely work on to find out the cheapest services provided by cloud, and we can deploy some data analytics tool there. So uh, mostly what I have seen, uh, mostly houses here in UK, they provide you the smart meter in your kitchen, and which really helps because you can see the consumption online. And now all the new home houses are basically having the solar panels on the top. So I have seen what people are doing. They keep on waiting for sun, and when the sun comes up, and then your consumption of electricity don't go up, and they will then at that time they will make use of all the electrical appliances like washing machine, dishwasher, vacuum cleaner. They will do most of their major stuffs at that time when the sun will be on the top. So and you can see the live result of your energy consumption on that meter, and that's because it's connected to your energy meter using the Zigbee, and it is connected to the server via the Wi-Fi. They use even many of them use cellular communication as well. So basically, when if we can convince the customer, it can be either some industry or a household, that you can save a lot when you use this particular device, then definitely you can get a good ROI. But yeah, when you are trying to develop a small prototype with a very cheap cost. So there are ways like you can select a small microcontroller like Raspberry Pis. Uh, you can definitely do using the ESP32 as well, but it's not trustworthy. We never know that what are the data they are sending. But definitely for prototypes, we can make use of ESP32 as well. But there is not much difference in the cost of ESP32 and PicoPi. So they would both have Wi-Fi connectivity. They uh, and it can be connected to your Zigbee module as well, which is basically I'm sure that energy meters in India also has having a Zigbee because Bestcom people whenever they come with a machine, so they get all the data using the Zigbee only. So that data can be basically can be read from the energy meter and can be displayed in a small console. So that's what they provide in the different households in Europe and US. And people keep on seeing people monitor the energy consumption every hour. So
This thing, the smart meters and all has been implemented in India also. It is most
mhm,
of the state they have done it, and
yeah,
even the meter reader earlier, what they used to do is they used to manually take down the reading. What was the current reading? That
mhm,
also has been done. Like we call it a smart meter reading apps.
yeah,
So they just show that scanner, then it capture the reading, then it will do the billing. At the
yes,
same time, it will send. It is all like internet connectivity available. Based on that, it will send the reading uh, to the mobile app also to the client so that they can see the end users. What is my consumption, and accordingly they may get some alert because now most of the it is in progress wherein prepaid meters wherein most like people have to pay the prepaid meter charge like how we used to charge the prepaid mobile connection same way they are working towards that. Maybe in Karnataka also they have started working for all the new domestic connections, they are giving prepaid meters.
okay, that's great.
And thank you very much. It was a nice session. We got to know something new.
Sure, thanks. Anyone else is having any question? Okay, if no one is having a question, then I will drop now. So yeah, thanks for joining and
Jazakallah.
uh, thanks.